and sketch the graph of f equals 3 bracket x plus 1 bracket square minus 12. So using the graph of x square, I need to be able to sketch the graph of the parabola on the left. So we need to use the transformations that I summarize on this whiteboard. The first transformation is the f bracket x plus a. This is a horizontal translation by a units, either right or left. If the number a is positive, it's going to the left. If the number of a is negative, it's going to the right. Now, if you see the parabola 3 bracket x plus 1 squared minus 12, the first transformation I need to apply, because the original function is the fx equals x squared. Okay, this is the original function. So I'm going to use the original function and sketch the second function. The first function is fx equals x squared. So the first thing to do is to use a translation, the x plus 1. You can see the bracket is x plus 1. So what I need to do is to replace the x with the x plus 1. And now the function becomes the x plus 1 bracket squared. And since it is a horizontal translation and the 1 is positive, the parabola is going to the left by 1 unit. So all this, the effect of this on the points, all the points, the x coordinates go 1 unit to the left. And if I consider the origin will go to -1, 0. Okay, I draw a different color. Let's make the purple color to be the horizontal translation. And if I check another point, for example, on the original parabola, this is the 2, 4. Okay, the 2, 4 is here. Okay, the 2, 4. Now the 2, 4 is going to go to 1, 4. Okay, so it's coming here. So this is a brief sketch. So obviously the parabola is going to this position in a symmetrical way, in the same shape. Okay, you don't expect to have a different, it's the same shape. So I apply a horizontal translation 1 unit to the left, and now the purple line represents the horizontal translation. Now to go and find the final function 3 bracket x plus 1 squared minus 12, I need to see what other transformations I need to use. Obviously I need to use the last one, the a times the fx, because I have a 3 in front of the function. If you see the 3 in front of the function, this is the a. So the other transformation, I need to do a y scaling by a factor of a. In this case is 3. So by using the 3fx plus 1, now if I do 3fx plus 1, the effect of this one, I go to the purple graph and I times the y coordinates by 3. The effect of this, the origin doesn't move. The -1, 0 doesn't move because this affects the y coordinates. Now the last transformation affects only the y coordinates. So the vertex of the parabola will stay at the original position, and you see the graph is going to be a bit more open, because if you consider some points, you can see the effect, for example, of this point. Let's check this point here, which is 1, 4. Now this point here is the 1, 4. Under this transformation, the point goes into the x doesn't change because it's a y scaling, it changed the 4. The 4 goes into 12. So it would be 112. 4 times 3 is 12. And so you see that the graph actually becomes more steep, more closed under this. So it becomes a bit higher. So if you go on to sketch this graph, basically the second transformation is the y scale, is the scaling. You make, it's a sketch, you don't need to be accurate on a sketch. You make the parabola more closed with the same vertex, the same minimum point here, because it doesn't affect the vertex. And the orange graph is the 3fx plus 1. And the other transformation I need to use to find the final position is the second. The second is a vertical translation because it's the function plus the a. The a here is outside the function. And this is the case when you have a minus 12 outside the function. This negative 12 is going to affect vertically the graph. Is going to go down by 12 units. So I need to move the orange graph 12 units down. And it's very obviously, you can see the points. This transformation affects only the y coordinates. They are going to go down by 12 units. So you move the orange graph 12 units down. So all you need to do is to move, let's use a different color. I'm going to use let's use the green. For the final position, you use the green graph. Now if you consider the corner here, which is minus 1, 0, the minus 1, 0 goes into minus 1, minus 12. So 1, 2, 3, 4. So let's say this is minus 12 here. So you bring the vertex here, the minimum point, and all the points go in the same direction. It goes down by 12 units. So it's easy to sketch. Now you have, for example, you can see that you have some other X-intercepts. So you see the graph is going to go into this position. And this graph is a sketch, which means it's a brief graph. Okay, this is the process of using graph transformations to sketch another graph. And both of these graphs are parabolas. Okay, so here I apply 3 transformations. I use one horizontal translation, one y scaling, and a vertical translation. Now, if the question is tell you to find the coordinates of the vertex is the lowest point of the parabola. And obviously, the minus 1, comma 0, it has gone into minus 1, comma minus 12, because the vertical translation affects only the y coordinates. They go down by 12 units. If I want to find the x-intercepts here, you need to solve the equation and make the f0 and find the x-intercept. For example, if they ask you to find the x-intercepts, then you may consider and solve the equation 3x plus 1 square minus 12 equal to 0. And this equation, you can solve this very easily using the methods. So the x plus 1 squared is equal to 4. The x plus 1 is equal to plus minus 2. So the x1 solution is 2 minus 1 is 1. So this point is 1, 0. Yes, this is a brief graph. This is 1 is 1. And the other solution is minus 2 minus 1 is minus 3. So the x-intercepts are 1, 0 and the minus 3, 0. And you also have these points here. And the other point here is the minus 3, 0. And this answers these questions. We sketch a parabola using the original graph of x squared. We found the vertex, we found the x and intercept, the y-intercept. If I want to find the y-intercept, I need to make x 0. I need to find what is the f comma 0. And it's very easily, can be found very easily by make x 0. So this is 3 bracket 0 plus 1 is 1 squared minus 12. This gives you 3 minus 12 is negative 9. And the y-intercept is 0 comma negative 9. And I apply here, I use the 3 transformations. One horizontal translation, the f bracket x plus a. The second is the vertical translation, fx plus a. The a is outside the function. And lastly, I use the a times fx, and this is a y scaling with a factor of a. This answers this question on graph transformations.